Hello, and welcome to my talk, Bugs Exposed, Unveiling Effective Strategies for Bug Bounty Programs, also known as actual methods I actually use to find actual bugs in actual bug bounty programs. That was actually going to be my actual title, but I decided to go something a bit more descriptive. My name is Douglas Day, also known as the Archangel on HackerOne or Archangel D-Day on Twitter. Just a quick primer before I get started. I'm going to go over briefly who I am and what this talk is about, as well as who I'm not and what this talk is not about, and then dive into a number of steps that I usually use to find success on bug bounty programs. So who am I? I'm a senior security engineer at Elastic. I joined in January of 2020 to build and run Elastic's bug bounty program. So if you're feeling particularly inspired at the end of this talk and want to look for a good program to hack on, I highly recommend my own program over at hackerone.com/elastic. But outside of work, I've been a bug bounty hunter for almost 5 years now. I actually started doing bug hunting right after seeing one of Ben's talks at B-Sides Portland in 2018. Went home and started my HackerOne account. And here we are 5 years or almost 5 years later, after having been to 14 live hacking events and having won 8 best collaboration awards. I'm also a Catholic, a father of 2, and soon to be 3, and a husband to an awesome wife who's a lot smarter than myself. And then outside of work and bug bounty hunting and being a family guy, I like playing board games, particularly Twilight Imperium 4th Edition for those that play. I'm a big Clan of Sar guy, and I also like to go snowboarding over on Mount Hood, which is just over in my backyard. Who I'm not. So I'm not your dad. You can take the advice I'm about to give or leave it. It's up to you. I'm not going to be proud of you either way. And I'm also not a recon expert. I have a lot of respect for the hackers out there who are able to run massive subdomain brute forcers to find lots of subdomain takeovers and obscure endpoints using FUF and content discovery. And that's a totally awesome way of hacking. I'm not that type of hacker, and so I have good recommendations, but this talk is not going to be about that. This talk is also not a definitive source of truth, or I mean, I'm not a definitive source of truth. The advice that I'm about to give has worked for me, but there might be better ways out there. You never know if I like to always be learning, and if I knew everything, then I would have to stop learning, and I don't want to do that. So what is this talk about? So this talk is just a number of methods that I've used over the last 5 years to bring me to the top 50 bug bounty hunters on the HackerOne platform. It's more of a way I think about programs when I approach them, rather than like tool suggestions. And so I actually recently wrote a tweet about 100 bug bounty tips, and you can go find it on my Twitter. But this talk is about 3 methodologies I typically use when approaching bug bounty programs. And this is also a look into how you can be a successful bug bounty hunter without having a massive recon engine. This talk is not, however, a how to start a bug bounty primer. You can find 101,000 treatises, talks, presentations, YouTube videos, slideshows, etc. about how to start in bug bounty. It's kind of a tried and exhausted topic. However, there's lots of good content out there if that's what you're looking for. This is just talking about the steps that I've taken to be successful for my own story. And this is not the only way to do bug hunting. Like I mentioned previously, there are a number of very good hackers who are super into automation and recon. I'm not one of those. There are also manual hackers out there like myself who hack differently than I do. And so these are steps that I've taken that have been successful for me. And so this may not even be the best way to do bug hunting. You might find that you can take what I give in this presentation, tweak it some, and get even better results. So, and I'm happy to hear about those if you do. So without much further ado, let's go into the first and largest way that I approach bug bounty hunting. So I've taught a number of people how to hunt for bugs, including my mother-in-law, my mother, my brother-in-law. I suppose just lots of family. And one of the most common reactions I get after showing them some of the reports I've written has been like, "Wait, that's a bug." And I think this is because there's this common misconception that the bugs that bug hunters find are all like SSRFs, XSS, SQLIs, RCEs, require a lot of like coding or automation or tools. Um, but the reality is that I find so many bugs just by understanding the logic of the application that I'm hacking on. So if you were to give me a brand new application, I'm not going to go spraying XSS everywhere. I'm not going to go try to find SSRFs. I'm not going to go, I'm just going to go into the application like a normal user and start looking for what I call no's. Now, no's aren't bugs themselves. But what they do is identify a place where a bug might be. So it's like an opportunity for a bug. Think of looking for no's like using a metal detector on the beach, and finding a no is like hearing that glorious like beep 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 sound. It still may be a piece of junk like a beer can or something, or in bug hunting not vulnerable, but it's definitely a place that you should dig. So the next question is, what are no's? All right, I'm telling you to go look for them. I should tell you what they are. So every application is different. They all have different business models, different functionalities, different uses, but a thing that they all have in common are security controls, trust boundaries, limits, permissions, etc. So anytime an application doesn't let you do something, this is a no. Maybe it doesn't let you access a certain part of the app until you have a paid subscription. This is a no. Maybe the app obfuscates the emails of the users. This is the app saying, no, you can't view these emails or view these users' emails. And so every time you find one of these no's, these are things that you should be trying to turn into yeses. Because if you were able to turn a no into a yes, you bypassed a security control, and that's typically a bug. Sometimes you'll find one where the impact is low enough that they don't care, or it's just broken like usability functionality, in which case it's not going to have much security impact. But typically, if you're able to bypass something the application developer said, no, you can't do this, then that's typically a bug that's worth reporting. So let's go into some examples. So here on the HackerOne application, after you file a report, you're told that you can edit the report for 20 minutes. Reading between the lines here, the application is telling you, no, you can't edit this report after 20 minutes. So there's your no. Now you ask, why is the application telling me no? If you could edit the report at any point, it would compromise the integrity of the triaging process. So being able to bypass this 20-minute lock would be a reportable bug. You may try editing the report after 19 minutes and then repeating the same request 2 minutes later. Or you may try creating a second report that's still editable, editing it and then modifying the ID to match the original report. There's a number of ways you can try to accomplish this, and I'm not going to try to go into what the best attack would be. But the gist of this is that if you can edit the report after that 20 minutes, then you've got a bug because you've turned that no into a yes. So if you go into the very next line, though, it lets you know that you can't edit the report after the program changes the report state. Now, this is another separate no, and bypassing this would be another reportable bug. So just within just a single tiny piece of functionality, we've already got 2 no's, and each no is a vector of attack and an opportunity for a bug. Excuse me. So let's go and look at another example. So here's a store-like application that lets you make gift registries and have other people purchase them for you. You know, say you're about to get married and you want a new Keurig or Magic Bullet or sofa, and you create this wedding registry that says, hey, I want these items. You can have people that are attending your wedding just log on to your registry and buy them for you, and they will get shipped to your address. As you can see in the invoice that's created, the full shipping address is hidden for privacy reasons. I think it says over there in parentheses, yeah, full address hidden for privacy reasons. This is because obviously you wouldn't want someone, just random person on the internet, going to your registry, buying, you something and then knowing where you live. So here's another no. It's no, you can't see this person's address. So when faced with a no like this, what I'm going to be trying to do is I'm going to be trying to find places in the application where that address does show up. So I might make a purchase on my own gift registry, like and then start control Fing through my like burp history looking for the address. Because there might be some obscure endpoint that still leaks the address. So either way, being able to get the shipping address of a user who you bought something off their gift registry for would be bypassing a no and turning it into a yes. Let's move on to a different application. So here in the Shopify Plus application, we see a no as soon as we go to the user management page. The application explicitly tells you that something can't be done. In this case, it's removing or suspending the organization owner. So if you're able to bypass this and as an admin user still be able to remove the organization owner, then you've successfully bypassed a trust boundary and by extension turned a no into a yes. Now on the very same page, we see another no when we click the suspend button on a user. The application tells you that after suspending them, no, they won't be able to log in. Another no. So now that we found a no, we know that we should try to find a way to log in to the organization after you've been suspended. Just spitballing here, you might try to see if you can use an API key that was tied to your user. Maybe after being suspended, it removed your user access, but any API keys that are still attached to you are still valid. I've actually seen that happen before. So that's a way you can try to turn the no into a yes. So while on the topic of users, you'll find that there are a lot of no's that can be found in user management. And oftentimes an application will let you configure your own no's that you can try to bypass. That's because role management's entire function is to let you choose where you want the no's to exist. So take Elasticsearch, for example. It's where I work, so I have a slight bias for it. Without going into much detail or nitty-gritty detail about how Elasticsearch works, it's possible when creating a role to specify exactly which data a user should be able to query on individual indices or data sets. In this example, the user here should be able to query all documents on the test index that have color equal to blue. We've been over enough examples recently that you should be able to pick out what the no is here. It's no, you can't query for documents that don't have the color equal to blue. And so your approach here as a bug bounty hunter is going to be trying to bypass that control. Another example within Elasticsearch is when creating API keys in enterprise search. Here on the key creation page, two no's stand out to me. The first is that when creating a key of the type public search key, the documentation explicitly says that these types of keys should only have access to search endpoints. So that's a no, these keys can't be used for non-search endpoints. So as a bug hunter, I'd be taking that API key, that's a public search key, and trying to hit every single non-search endpoint to try to bypass that no. And if you can do that, then you've got bugs on typically every endpoint that you're able to hit, depending on how the application is programmed. They might all dupe into one, but either way, you at least got one bug. The other no is a bit more obvious, and it's that you can specify exactly which engine the key has access to. In this example, the app says, no, this key doesn't have access to engine 2. So I'd trying to use the key to access engine 2. So we've been over a lot of no's that you can look for. But one note I'll bring up is that just because you can bypass a no, you still need to evaluate the actual impact. I touched on this briefly at the beginning of the talk. But for example, here we see the application saying, excuse me, I got the hiccups. No, the application can't be less than 6 characters long. But the impact of bypassing the no in this case is simply that a user could intentionally shoot themselves in the foot. So please don't report stuff like this. Take a step back, think, okay, why is the application telling me no? Is it because bypassing the no would have security impact? Or are they just putting a control in there to make usability easier? In this case, that's the case in this case. So moving on from no's, another method that I typically use, and this is, I'll preface this by saying that the extent at how detailed I go into this method varies from target to target and how exhausted I am. But for those that aren't familiar, or the method is called RBAC matrixing. So for those that aren't familiar with the acronym RBAC, or for those of you that aren't familiar with the acronym, RBAC stands for role-based access control. And it's basically the concept that applications can have multiple different types of roles, and each role has differing permissions. typically there's like 3 or more roles, like an admin, a normal user, and then some type of low-level user like read-only. But the problem is that it's extremely difficult to programmatically protect every single endpoint in an RBAC structure. So as a bug bounty hunter, what I like to do is chart out the application as the highest possible permissioned user. So I'll typically go in as an admin and just browse every single set of functionality, save all those requests in Burp Suite, and then map out mentally. Or if I'm being extremely detailed, like in a live hacking event or something, I'll make a spreadsheet have what the intended functionality is supposed to look like on in the matrix, and then I can methodically start going through the matrix, starting usually with the lowest level user, and see if I can bypass controls. So, for example, in our example here, we might have a matrix that has admin users, manager users, read-only users, and if you're unauth, then we'll just call that unauth users. And then we've got different pieces of functionality that the user might be able to do. So in this case, an admin can do everything, a manager can do everything except user management, a read-only can read reports, and then you shouldn't be able to do anything while being unauthed. So after going through your RBAC matrix and being diligent, you might find in our example that the manager users can delete other users and that you can read reports while unauthed. So this would be 2 separate vulnerabilities. You can report that an unauth user can read reports, and you can report that a manager user can delete other users. So using a concrete example, let's take HackerOne. HackerOne's a bit interesting in that you can create custom roles, but it should still work if we treat permission type as a separate role. So I think there's 4. Sorry, my little notes are very small. There's program admins, rewards, reports, and read-only. So let's see. Yeah. So here's a quick stab at what an RBAC matrix might look like. Of course, it's going to be a bit more complex than this in real life. But at this point, I'm usually going to start with the least permissioned role and work upwards. This is because if I find that an endpoint isn't protected by the lowest level user, it'll have the highest impact. So for example, let's say that the lowest level user and a middle level user are both able to award bounties. Clearly, the highest impact is that the lowest level user can award bounties, so that's the one I'm going to report. So starting with read-only users, we may find that they can't award bounties, but they can still hit the endpoint that lets them suggest bounties. Again, this is all hypothetical. This isn't like a live bug or anything. But in this case, we can confidently file a privilege escalation bug. Hooray. And so this is a way you can just be extremely thorough when an application has a complex RBAC structure, because I'll see situations where only like a single endpoint and a single verb are vulnerable. Maybe a user shouldn't be able to get some object or modify some object or delete some object, and the authorization is happening on getting the object and modifying the object, but not deleting the object. And so it's really important, especially when you're going really deep on an application that's been hardened and tested for a while, to go and be thorough and try testing these authorization bugs or privilege escalations in a methodical manner using an RBAC matrix. So lastly, I want to talk about how I usually spend the first 30 minutes on a new program. And I'm going to preface this by saying that this is typically in the context of a SaaS application. I do hack on non-SaaS applications, but the programs that I like the best and that I go the hardest on are ones that are SaaS, where you can usually self-service, spin up a free trial, have an organization structure, etc. And they're all divided by tenant. So sometimes you get invited to a brand new program, and there's a lot of other hackers who are about to take a look. You don't always have time to go read the documentation, go deep, write out a matrix for the RBAC structure, and you also don't want to dupe. So what do? there's a number of things that I try right away to find high impact bugs right off the bat. So here's how I typically spend the first 30 minutes, give or take, on a brand new SaaS application. So the very first thing I do is go to user management. This is because of my experience. Account takeovers are the quickest and easiest to find criticals. I have found criticals that are not account takeovers, but the most common critical vulnerability that I will find is either some highly impactful IDOR or account takeovers. And account takeovers are very common. Well, okay, I won't say very common, but they are more common than in other areas in user management. And so what am I looking for in user management exactly? So the very first part of a SaaS application that I look for, or excuse me, if the very first part of a SaaS application that I go to is user management, then the first part of user management that I go to is invites. And that's because there's a plethora of potential vulnerabilities that you can find using invite functionality. For example, one of the very first things I'm going to try to do is invite existing users to my organization. So one of the quickest bugs that I'll find is if you have two organizations within a SaaS application, and I invite a user that exists in another organization, in my pending invites, it will often expose their full name. So it'll say, I can invite douglasday@gmail.com. Before they even accept the invite, it'll say, oh, Douglas Day is a pending invite. And so being able to just know someone's email address and then get their name, or then using the application to get their full name is typically a pretty low-hanging, low or medium severity bug. But beyond that, one of my favorite bugs that I like to tell or talk about, because I found this within 30 minutes of the application or of a program launching, is that occasionally you'll have a SaaS application. Occasionally you have a SaaS application that lets you exist in multiple organizations. And I had a SaaS application one time that I was testing. It had just launched, and I found that you can invite other users that exist in other orgs. But it also didn't require them to accept the invite. It just put them in your org. That's all fine and dandy. You might think, okay, it's just kind of annoying that someone can just add me into their org. But the problem was that because I'm an admin of my own org, I had the ability to modify the email addresses of any other users that were in my organization. And so if I wanted to take over your account, what I could do is invite you to my organization, then as my own org admin, modify your email address. And then now that I've modified your email address, I can go through the password reset functionality, change your password, and then log into your organization. So it was effectively an entire organization takeover just by using the invite functionality. Additionally, a thing you can try is inviting yourself to other orgs. I had one instance where upon accepting an invite, the request that was sent to you just used an iterable invite ID. And so I could modify the invite ID and it would make me accept somebody else's invite. And so I could effectively invite myself or hijack invites into other organizations. So that's one thing I look for in invite functionality, is whether or not the invite code is iterable. I'll also see if the invites expire. Occasionally, you'll have an application where you might invite a user to your organization, but then remove them, like cancel the invite, or remove them from the organization. What I've seen happen before is that the invite itself doesn't expire, especially if there were multiple invites. And so if I were to get kicked out of say I accepted an invite into an organization, then I left the company, got removed from the organization, I could still use an old invite to rejoin the organization after being removed. Additionally, when accepting an invite, you can occasionally or I will check to see if I can modify the role, see if the role is in the invite request. So for example, let's say there's an application where a user has the ability to invite other users, but they don't have the but that user itself is not a full admin. Like, let's say I can invite other users to have my own permissions, but not have permissions higher than myself. What I might try to do is I might try to invite another user, and then in the request, change the role that of the user that I'm sending the invite to a higher role than myself, to effectively escalate my own permissions. And there's a number of things you can do. One of the final things that I will occasionally do is just look for HTML injection on the invite emails. That seems to be a very common vulnerability. It's typically a low, but it's an easy one to milk out of an application. So I might use if the invite functionality lets me change or set the user's name, I might try just using italic tags and see if I can get HTML injection on the email template that is sent to the user. There's a number of things you can do with invites, but that's typically, messing with the invite functionality is generally how I spend the first 30 minutes of any on any SaaS program. So I'm about out of time, but in summary, the number one thing I do is look for no's, followed by making an RBAC structure to chart out the RBAC structure, and then make a matrix. And then on a new program, I go straight to user management and look for oddities in user management and invite functionality. I think there might be time for Q&A in the chat, and I am happy to answer any questions that you might have. Thank you, everyone, for listening to my talk. And thanks, Ben, for hosting NahamCon. It's been a pleasure.